Welcome to this lesson on creating Kubernetes secrets with Base64 encoding. In this video, you will learn how to properly create and encode secret data in Kubernetes. Base64 encoding is a fundamental concept that every Kubernetes user should understand when working with sensitive information. By the end of this lesson, you will be confident in managing secrets effectively and understanding when and how to use Base64 encoding. Let's start by understanding what Kubernetes secrets are. Secrets are special Kubernetes objects designed to store sensitive information such as passwords, tokens, and SSH keys. The primary purpose of secrets is to keep confidential data separate from your application code and container images, ensuring better security practices. Once created, secrets can be used in your pods by mounting them as volumes or exposing them as environment variables, making sensitive data available to your applications without hard-coding it. You might wonder why Kubernetes requires Base64 encoding for secrets. There are three main reasons. First, Base64 converts binary data into a text-safe format using SCII characters, making it safe to store in YAML or JSON files. Second, it prevents data corruption when transmitting information through text-based systems. Third, Kubernetes specifically requires the data field in secrets to contain Base64 encoded values. However, it's crucial to understand that Base64 is encoding, not encryption. This means anyone can easily decode Base64 data, so it does not provide security on its own. Let's explore the fundamentals of Base64 encoding. Base64 uses a character set of 64 characters, which includes uppercase A through Z, lowercase a through Z, digits 0 through 9, and two special characters, plus and /. The conversion process works by grouping 3 bytes, which equals 24 bits, into 4 Base64 characters. This transformation results in an output that is approximately 33% larger than the input. The good news is that Base64 encoding is completely reversible, meaning you can easily decode the data back to its original form whenever needed. Understanding the Base64 encoding process helps demystify how it works. The process follows 4 steps. Step 1. Convert your input data into binary representation, where each character becomes 8 bits. Step 2. Split this binary data into groups of 6 bits each. Step 3. Map each 6-bit value to its corresponding Base64 character using the Base64 character table. Step 4. Add padding with equal signs if needed to make the output length a multiple of 4. This systematic approach ensures consistent and reliable encoding of any data. Let's see Base64 encoding in action with practical examples. To encode a string to Base64, you can use the command echo-n followed by your text in quotes, then pipe it to Base64. For instance, encoding my secret password produces the Base64 output BXLZZ WNY ZXRWY XNZD2 9YZA ==. You can also encode data from a file by using cat followed by the file name, then piping it to Base64. These commands are essential tools for manually creating Base64 encoded values for your Kubernetes secrets. When creating secrets using the data field, there's an important requirement to remember. All values must be Base64 encoded before you add them to the YAML file. In your secret manifest, you specify API version v1, kind secret, provide metadata with a name, set the type to opaque, and then use the data field. Under data, each key-value pair requires the value to be Base64 encoded. For example, username might be YWRT a W4 equals, and password would be BXLZZWNY ZXRWY XNZD2 9YZA ==. This manual encoding gives you full control, but requires extra steps. Kubernetes provides a more convenient alternative called the stringData field. When using stringData, you can write your sensitive values in plain text directly in the manifest file without manually encoding them to Base64. The structure is identical to using the data field, but instead of data, you specify stringData. Under stringData, you can write username as admin and password as my secret password in plain text. Kubernetes automatically handles the Base64 encoding for you behind the scenes. This approach is much more user-friendly and reduces the chance of encoding errors, making it the preferred method for most users. Decoding Base64 encoded data is just as important as encoding it. To decode a Base64 string, use the echo command with your encoded value in quotes. Pipe it to Base64 with the -- decode flag. For example, decoding BXLZZWNY, ZXRWYXNZD, 29, YZA == returns the original text my secret password. You can also retrieve and decode secrets directly from Kubernetes using kubectl get secret, followed by the secret name, then -o JSON path = curlybrace.data.password curlybrace, pipe to Base64 - decode. This command fetches the secret and immediately decodes it for you. Let's recap the key takeaways from this lesson. First, remember that Base64 is encoding, not encryption. Anyone can decode it, so it doesn't provide security by itself. Second, use the data field when you need to manually provide Base64 encoded values for your secrets. Third, use the string data field for plain text values, as Kubernetes will automatically encode them for you, making the process simpler. Fourth, always implement encryption at rest for production secrets to ensure your sensitive data is truly protected. By mastering Base64 encoding, you now have the foundational knowledge needed for effective secret management in Kubernetes.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.